In this lesson, we're going to explore graphs of periodic functions. The graph below shows a typical sinusoidal function. In this case, the x-axis is the median line of the sinusoidal function. The midline or median line is sometimes called the axis of the sine function and is a horizontal line midway between the maximum and minimum values of the sine curve. So if you look here, our maximum is up here. Our minimum is down here, and then we've got this horizontal line which we call the median line, midline, or axis. So you're going to need a straight edge for this lesson because we're going to be drawing in that median line, and then we're going to be measuring the amplitude. Well, what is the amplitude? The amplitude is the distance of the curve from the median line to either the maximum or the minimum. It's always expressed as a positive value, whether you're measuring up or measuring down. Okay, so we count that as the amplitude. We've already measured the period, and we're going to continue to do that. The period is the length of the shortest interval in which the wave repeats itself. So we're looking for repeating waves. The period in our investigation was 360 degrees. It is the length of the interval of the domain to complete one cycle. So you can see in this graph, we can have the period from this point to this point, that's one complete cycle, or we can have it from this point to this point here, if we do one more, which is one complete cycle. So it's wherever it's easiest to measure, so you can measure it in various lengths, but one period is you're going to measure from one repeat, okay, where you can see it repeat itself once. Alright, let's take a look at a question where we can actually test some of these properties out. So example 1 says the graph shows the number of hours of daylight in Winnipeg for about 1100 days. Okay, so that's an interesting value. Why 1100 days? And we'll have a look at that. So if we first just look at the graph before we even start anything else, before we look at the questions, what is this graph showing me? Well, I can see I've got a formula here. So it's telling me it's a sine function of some sort, but there's lots of other stuff going on in there. We can also see that my graph isn't sitting at 0 like previous graphs have. It's up in the air here. I can see that I've got on the bottom, that's time in days, so that's that 1100 days measured across the bottom. And then the daylight is on the dependent side. So the daylight hours, so that's measuring how many hours of daylight. And if we think of our day, right, the number of hours of daylight in our day, and we can see that fluctuating. So what might that be fluctuating? Why might that be fluctuating, right? So you're thinking back to maybe our seasons, maybe how we rotate, right? Both around ourselves and then around the sun. So these are all factors that are coming into play with how this is moving around. Now, it says, use the graph to answer the following questions. In each case, state the values and then state the significance of these values. So they want a numerical answer and then an explanation about what that might mean. So what are the minimum and maximum values? Well, the minimum values are the lowest points, right, on our graph, and our maximum values are the highest points on the graph. Now, it would be really nice to have grid lines on here because it's sort of hard to measure, but what you might want to do is take a straight edge and draw that across to see where that lines up. And that's what I'm going to do right now. Alright, so for my maximum, when I drew my line across, you can see that it's more than 15. Okay, so if that's measuring in increments, it's about 16 or 17 hours. Okay, if you look at that. And then the bottom one for the minimum, I actually probably didn't need to draw the line because you can see that that value is sitting right there where the graph starts. And that's about 8 hours. Okay, so let's write that down. I'm going to erase those lines because I'm going to need that information or that room for some other stuff. So minimum is 8 hours and maximum is 16 hours. But again, they don't want to just know what those values are, but they want to know what they mean. So think about our seasons again. When do we have the least amount of daylight, right? And when do we have the most amount of daylight? So this is the amount of daylight on our shortest and our longest days of the year. Our longest day of the year is our summer solstice, June 21st, and the longest day of the year is our winter solstice, and that's December 21st. So if we go back and look at our graph again, okay, so you can see our longest day is shown 3 times, and our shortest day is shown just about 3 times, right? A little bit longer, and that would have been 3 times. So in terms of the amount of time shown here, right, does that make sense that it's 3 years? Yes, it definitely does. Because if we're seeing 3 summer solstices and 3 winter solstices, well, that means that 3 years have gone by. So that's that 1100 days, 3 years, 365 days for 1 year, right? Times 3. That gives you 1095. So that's short of 3 years. And if we have 365.25, which is really what our year is, times 3, right? That's even closer. So that's what they're talking about in terms of the period, the 3-year time frame. And we can see our 3 summer and winter solstices, longest and shortest days of the year. Now the median value, or the axis, well, that's not shown on my graph, but if I know the maximum and I know the minimum, then I should be able to solve for that median value, okay? So how do we solve for the midpoint? Well, we take those 2 values and add them together. So if we have our maximum and we add that to our minimum, divide that by 2, we should get our median, or our axis. Using our values, that would be 8 plus, well, if I'm going to do maximum, 16 plus 8 divided by 2, or 24 divided by 2, which is 12. Now, when we're stating our axis, it's actually an equation. So that equation would be a horizontal line, so that would give us y is equal to 12 as the equation. Now taking your straight line, we can draw our horizontal line in at y equals 12. So go ahead and do that now. Alright, once you have that drawn in, you can also label it so we can see what that is on our graph. Because the next question that we're being asked is, what does that actually mean? Well, in a day, we have 24 hours. 12 is half of that, so that makes sense that the 16 plus 8 gave us 24, and half of that is 12, so that means we have the same amount of daylight as we do darkness. So let's add that to our information here. When we have the equal amount of daylight and darkness, that's our spring and fall equinox. So if you look up at our graph, you can see the points where our curve meet the line would represent our spring and fall equinox, and you can see those throughout the year. The next question being asked of us is to solve for the amplitude. If you remember, the amplitude is the difference between the median line and the max, right? This would be one amplitude, or the median line and the min. And those are the same heights. That's the amplitude. But what is the value of the amplitude? That's what we really want to know. Well, if 12 is our midline and our max is 16 and our min is 8, we can see that that difference is going to be 4 hours, right? So if we take our 16 minus 12, that would be 4. Or if you take your 12 minus 8, that would be 4. So either way you do that, you should get the same answer. So the amplitude is 4 hours. And what does that 4 hours represent? Well, it represents the difference between a solstice and an equinox in hours of daylight. If we look back up here, so our maximum value is 16. Our minimum value is 8. And then that difference here is 4. So that's what we're looking at for amplitude. So if we take that median line, which is 12, that's our solstice, the difference between that and our max or that and our min is that 4 hours. All right. Number 4 says the period. So what is the period? And we've talked about that already. Because we've got 3 years shown, we can see one repeat in a cycle would be 1 year, right? So the period is 365 days or 1 year. And we know that there's 3 years shown in the graph. All right, so that's just one example of where we can see periodic behavior in a real life situation, and we can analyze the amplitude, the max, the min, the period, and so on to actually give it meaning. All right, let's take a look at another example. Now, we should be able to graph our functions here. Now, when you're using your graphing calculator, you will need to set the window accordingly depending on whether you're graphing in degrees or graphing in radians, okay? So what we're going to do is we're going to graph the y equals sine x function in degrees and radians, making sure that our window settings are set accordingly, and then we'll talk about the different characteristics both in degrees and then in radians. So the way I'm going to do this in 2 different colors and then state the domain in one color for degrees and the other color for radians. Then what we're going to do is we're going to do this all over again for the cosine function. So we're going to see how to set up the graphing calculator, and then we're going to graph it and look at the characteristics. Once we have a really good understanding of these 2 functions, then we can start doing stuff with them. We're going to start manipulating them, transforming them, squishing them, stretching them, moving up and down, left and right, and so on. So let's get a really good understanding of what this looks like and how we can actually see these functions on our calculators. So the first graph we're going to look at is the sine graph, and you're going to want to make sure your settings are as follows. So 4 degrees, you're going to want your min to be 0, your max to be 360, your scale to be 90, your min to be -2, your max to be 2, and your y scale to be 1. Now, the way I have it set up is you're actually just graphing this part. If you want to go from -360, you can always change this to -360, and then you get the whole graph shown. Okay? So, depending on what you want to actually look at in terms of your graph. But if we just start at 0, we can see what's going on with the rest of it. So let's just start with our calculator in degrees and graph y equals sine x. So let's go ahead and do that. Clear out what we had before. So I'm going to go to mode, make sure I'm in degree mode. If you've reset your calculator recently, make sure that it automatically goes into radian as default, so make sure it's in degrees. Go into our window and set our window according to what we just wrote down. So our 0 max is 360. Now, there's some times where you're not going to want your scale to be 90. I just have it counting up by 90 degrees right now. But maybe sometimes you want it at 30 degrees. Maybe you want it at 10 degrees. That's going to be the tick marks that are drawn along your x-axis there. So right now we're just going to count up by 90 degree increments because that's for the sine graph. We know that those are where our key features are going to be. My y min is -2. Y max is 2, and then the y scale is fine to just count up by 1. If you want to count up by something different again, you can change that as you need it. So let's go and put in our graph here. Make sure your plots are off, and I'm going to put in sine of x and then trace. Okay, so you can see the tick marks there. I'm going from -2 to 2, but my graph is actually going from -1 to 1, right? My maximum and minimum points. I've got my cursor here blinking at 180 degrees, which is half the period. Full period would be 360, and you can see there's a tick mark on either side measuring 90 and 270 degrees, which is the exact tick marks that we have on our grid, right, on our graph drawn in our notes. So that's why I set it up that way. You can adjust those settings as you need. When we start manipulating our graphs around, you're going to want to see some of those other features. Okay, so let's go ahead and draw this in. So we have the same image here. Now we've got our graph going from 2 to -2, and the scale is 1. So that's what, oops, that's not -2. That's -1. So that's what you see in your graph there. So our sine graph starts at 0. At 90 degrees is up at 1. 190 degrees it's down at 0. 270 degrees it's at -1. And then we're back up at 360 degrees at 0. So draw a smooth curve through that. Now, if you want to show the opposite side, you can go ahead and do that as well. And it would be the same graph going the other way, right? So if we're going in the other direction, we can go at -90 degrees, right? We'd keep going down. That would be at -1, -180 degrees, 270 degrees, and then back down to 360 degrees. You can see that smooth curve through there. Now, if you wanted that to be shown on your calculator, all you have to do is change your window and change that to -360 and then hit trace, and you can see that all of that will be shown there. Okay? So, in terms of our domain, the domain of the sine function does go from -infinity to infinity, but in this case, all we have shown, we've only graphed from -360 degrees to 360 degrees. Okay? Now our range, that's our y values, they go from, right, because this is x and this is y, they go from -1 to 1. We don't surpass that. And the median or midline, in this case, we haven't shifted the graph anywhere. So the median line is our x-axis, and that would be the equation y equals 0. Amplitude is the height. So from there to the maximum, right? From the x-axis to the maximum, or from the x-axis to the minimum. Now let's take a look at the period. Now the period is where we have one repetition. So if we start at any point on the graph, let's say I started here, where does that part repeat again? And that would be at 360 degrees. And you could do that anywhere along the graph. Okay, so if you wanted to start here and go to here, even though it's going from -270 to 90, that's still a difference of 360 degrees. So that would be 360 degrees for a period. Now our x-intercepts, you can see along the graph, we're at -360, 180, 0, 180, and 360. Don't forget to put the negatives for the negative ones there. And finally, so those are all degrees, sorry. And finally, for our y-intercept, you can see that that's at 0 as well. Okay, so we're going to do this all over again, and we're going to do this in radians. Now, what you're going to be looking at is going to be exactly the same, instead we're using different units. So let's have a look at that in our calculators first. Now when you're setting your window for radians, again, you can change this to -2 pi if you don't want it at 0. That's fine. But you can put the 2 pi right in there, and your calculator will put it in decimal place or whatever you need to do. But just put it right in like that. So let's go ahead and do that. So if I change from -360 to -2, and then just put the pi right in there, and that'll be fine. And it'll adjust it as necessary. So clear that out and put 2 pi in there. What did we have it climbing by in terms of our scale in our x? 0.5 pi. So that's fine too. And then we went from -2 to 2. Now, in terms of your mode, you could put that in radians now. And make sure that you have your sine x function in there and hit trace, and you should see that exact same picture that we got before. But now this is graphing in radian mode. Okay, so let's go ahead and draw that in. So let's use our other color here. We're going again to 1, but we can put 2 on there just so that we can see where it's going. And these are negative. So we start at 0, 0, and then halfway we're at pi 0, and then at the end we're at 2 pi 0, and then halfway between 0 and pi by 2 we're at a maximum, halfway between pi and 2 pi we're at a minimum, and our graph will look something like this. So it's really important for you to identify those key points where they're placed on this parent function, because then what we're going to be doing is we're going to be adjusting this graph. We're going to be shifting it up and down, left and right, squeezing it, stretching it out, and so on. So as long as you can really understand both in degrees and radians what this function looks like normally, then once we move things around it'll become a little bit more easier. So if you want to extend the graph to -2 pi, you can go ahead and do that, and it's going to have those same values there. So if we want to do that, we can go, our 2 pi's go to 0, our pi's go to 0, halfway in between we're down at a minimum, and halfway in between -2 pi and -pi we're at our maximum. And this would look like this. And it's going to continue on like this from -infinity to infinity. So in terms of our characteristics here, the domain hasn't changed, except we're going from -2 pi to 2 pi now. Our range is still the same. Our midline or median line is the same. Our amplitude is the same. Our period is now 2 pi. And our x-intercepts we can read right off of there. We've got -2 pi, -pi, still 0, and then pi and 2 pi. Alright? And our y-intercept is 0. Now in terms of the period again, so where do we see that repetition? So we're measuring from here to here. That's one repeat, so that's why we have 2 pi there. Alright, we're going to go ahead and do this again on the next page, and instead of having our sine function, we're going to be graphing our cosine function. In terms of your window settings, those are exactly the same, but now you're graphing y equals cos x. So rather than me going through all of that, you go ahead and do that, and then come back and check, and you should see all the characteristics. So here you have the graph of y equals cos x. You can see it in degrees and in radians, the same behavior. If you look down here, our domain goes from -infinity to infinity, although I've only graphed from -360 to 360 in terms of pi radians, -2 pi to 2 pi. The range, the minimum is -1, the maximum is 1, so that's our range there. Median or midline is still the x-axis at y equals 0. Our amplitude is 1, because that's the height, right? You're saying from the midline up is 1, from the midline down is 1. And our period is 360 degrees or 2 pi. So what does that mean? That means that that's where we have one repetition. So if I go from this point to this point again, That's one full cycle, one repetition, 360 degrees. And if we look at that on our other graph here in pi radians, that would be 2 pi. In terms of our x-intercepts, that looks a little bit different than in our sine function as well. We have negative 270, negative 90, 90, and 270. And then in terms of pi radians, negative 1.5 pi, negative 0.5 pi, 0.5 pi, and 1.5 pi. And our y-intercept is 1. On the next page, there's a nice summary of everything we've learned. So the key ideas are summarized here. And if we look down here, we can see the difference between the sine graph and the cosine graph and those characteristics as well. That's it for today's lesson. Thanks for joining me.